All right, guys, welcome back to the log unit. Again, actually, we're in Unit 10 this year. We've rearranged. Today's lesson, after we do the log song, woohoo, is going to be solving logarithmic application problems. And then again, you'll have some time at the end of class that you can, or at the end of this, that you can practice some on your own. So here's the fun part, the log song.
One rolled downstairs, older and pears rolled over your neighbor's dog. What's great for a snack and fits on your back? It's log, log, log. It's log, log. It's big, it's heavy, it's wood. It's log, log. It's better than that, it's good. Everyone wants a log. You're gonna love it log. Come on and get your log. Everyone needs a log.
Log from Blammo.
All right, there we go. Have you got that thing memorized yet? It's kind of fun. All right, so we have some applications of log functions in real life. Magnitudes of earthquakes, so the strength at which the earthquake actually shakes the ground. Sound, the decibel levels, so how loud and how quiet are things. pH, you're hearing a lot about pH these days, particularly like with your alkaline waters and that kind of thing. And then the last thing is cooling times of some things. So as you put a cup of tea on the counter, how long does it take to get to room temperature? So these are some examples. You're going to have formulas for each of them. So maybe make yourself a little note card with each of the formulas so you don't have to like flip around and find it every single time we're going through these. The pH formula is pH equals negative of log of H plus. That H plus notation is the hydrogen ion concentration. For magnitude of earthquakes, we have M, the magnitude, equals log of I over S, I being the intensity over S being the standard intensity, which we just use as a 1. So it's really log of the intensity. If you're comparing earthquakes, you can take the magnitude of the first minus the magnitude of the second and set that equal to log of the ratio of their intensities, intensity of the first earthquake divided by the intensity of the second earthquake. And a couple of different ways that you can solve for sound intensity. dB, the decibels, equals 10 multiplied by log of I over I sub 0. And I sub 0 is 10 to the negative 12th power. So hopefully you got those down pat. Take a minute, pause if you have to, jot them down so that you know the ones that we're going to be using as we go through. Here's our first example. And this one we're going to be dealing with pH. So again, our pH formula is pH equals negative multiplied by log of the hydrogen ion concentration, that H plus in brackets. Determine the pH of blood if the hydrogen ion concentration of human blood was measured to be H plus equaling 3.16 multiplied by 10 to the negative 8. All right, so hopefully we hope our blood is not acidic. We don't want it to be that way. So we're just going to actually look for the actual pH of blood based upon this information. So just substitute in what you have. pH equals negative log of your hydrogen ion concentration, which in this case is 3.16 multiplied by 10 to the power of negative 8. When you type all this lovely stuff into your calculator, takes just a second, you should get a value of about 7.5. So the pH of our blood is, for this particular example, about 7.5, which is in that neutral range. It's almost to the alkaline, but neutral is where we want to be. Here we go for the next one. All right, the most acidic rainfall ever measured occurred in Scotland in 1974, and the pH was 2.4. So we are way over here. There's my 2.4 value on our scale. Determine the hydrogen ion concentration. So this example, we're going to work backwards. We're going to start with our formula, pH equals negative multiplied by log. Again, that's base 10, don't forget, of your hydrogen ion concentration. This time they tell us the pH is actually 2.4. So that equals negative log of our hydrogen ion concentration. We do need to isolate the log. So we're first going to divide through by the -1. So negative 2.4 equals log of our hydrogen ion concentration. And in order to get rid of log base 10, we need to exponentiate or rewrite an exponential form, 100%, whichever way you choose. I'm going to exponentiate because I know that's log base 10. So I can do 10 to the power of negative 2.4 equals 10 to the power of log base 10 of the hydrogen ion concentration. So once I exponentiate or rewrite an exponential form like I just did, you can just type this into your calculator, 10 to the negative 2.4, and that will tell us our hydrogen ion concentration. So in this case, we get a value of 0.00398 to equal the hydrogen ion concentration. And yes, you should use that proper notation. Here we go. All right, let's try some new ones. All right, now we're going to talk about earthquakes. In 1906, an earthquake in San Francisco had an estimated magnitude of 8.3 on the Richter scale. In the same year, a powerful earthquake occurred on the Colombia-Ecuador border and was 4 times as intense that of the one in San Francisco. Determine the magnitude, or what was the magnitude of the earthquake on the Richter scale for the Colombian Ecuador earthquake. Okay, so we've got a couple of different things we need to make note of. First of all, just a little note to myself, San Francisco's had a magnitude of 8.3, and the Colombian Ecuador had 4 multiplied by the intensity. So it's 4 times as intense. Okay, so remember, M is going to represent our magnitude and I is going to represent the intensity. So we are first going to do a couple of different things. The first thing we're going to look at is actually determine what is the intensity of the San Fran earthquake. I need to know that because then I'm going to multiply that by 4 to get that of the Colombian Ecuador earthquake. So I know its magnitude, M, equals log base 10 of I over S, where S equals 1. So the magnitude that we have is 8.3. That equals log of the intensity. And you can just put log of I because, again, S represents the standard, which just has a value of 1. Just as we did in a previous example, this is log base 10. So I'm going to exponentiate both sides, or you're going to rewrite an exponential form. So it's 10 to the power of 8.3 equals the intensity of the San Fran earthquake. Sorry, there's my R. There we go. All right, next thing that we need to do is actually determine what is the magnitude of the Colombian Ecuador earthquake. So our magnitude is going to be log of 4 multiplied by the intensity. It's 4 times the original intensity of the San Fran quake. So this is going to be log of 4 multiplied by 10 to the power of 8.3. Type all of this mess into your calculator and you get a magnitude of 8.9. And again, that is for the Colombian Ecuador earthquake. So our San Fran had a Richter scale magnitude reading of 8.3. And even though the Colombian Ecuador one was 4 times more intense, like you felt it 4 times worse, it only went up a teeny bit on the Richter scale. At least that's what it looks like, from 8.3 to 8.9. All right, another one about earthquakes. In 1989, the Loma Prieta earthquake that shook San Francisco had a magnitude of 7.1. Poor San Fran, man, they're just getting earthquakes all the time. How many times more intense was the 1906 1906 earthquake, which was an 8.3 on the Richter scale, than the one that occurred in 1989. So we're comparing magnitudes. We're comparing the 1906 to the 1989 earthquakes. The one in 89 had a 7.1 Richter scale, and the one in 1906 had an 8.3. So how much more intense is the one that happened in 1906 than that in 1909? In this case, because we are looking for the comparison of the magnitudes, we're going to take the magnitude of the first minus the magnitude of the second, equaling log of the intensities. Intensity of the first over intensity of the second, the ratio of them. We're just going to substitute in all the info that we know. Plug and chug. Here we go. So the first one is an 8.3. The second earthquake was a 7.1. And then we're going to have log of the ratio of the intensities. So this gives us 1.2 equals log of the ratio of the intensities. And then again, we would exponentiate or rewrite in exponential form 10 to the power of 1.2, 10 to the power of log base 10 of the intensities. So 10 to the power of 1.2 equals the ratio of the intensities. So when we actually type in 10 to the power of 1.2 into your calculator, you determine that its value is approximately 15.8489. So we'll just say 15.85. That means, since we're looking at the comparison, the 1906 earthquake was almost 16 times. So it was 15.85 times more intense than the earthquake in 1989. 1989. So quite a big difference. Wow. I'm not moving out there. All right. The other ones that we haven't done yet are sound decibels, or looking at decibel levels of sound, excuse me. So determine the decibel intensity level of a jet engine during takeoff if the intensity was measured at 100 W's per m squared. That is watts per meter squared. Alrighty, so if you look at our little chart that we have, I kind of like this, it's kind of neat. So normal conversation is right here at 60, so that's just us chit-chatting. A motorcycle is all the way up to 60, and fireworks are technically intolerable, and that's a meter away, so about 3 feet away from you. They have a sound level of 150 decibels, which is pretty much intolerable. Now you understand why poor puppy dogs and all the other animals can't stand those things. It scares them, hurting their ears. All right, so we have the decibel level equals, here's our equation, 10 multiplied by log of the intensity over the initial intensity. Okay, remember I sub 0 is 10 to the power of negative 12. And again, that would be watts per meter squared. So substitute in the info that we have so we can solve. The decibels, dB, equals 10 times log of, let's see, it said 100 over the initial is 10 to the power of negative 12. You can straight up type that into your calculator and get the answer. The decibel level should be about 140 for the jet when you type all that in. And so that's just under fireworks, not much quieter. And our last example for the day, the intensity of the sound of a subway train was measured at 98 decibels. So looking at our chart, shouting conversation, but most closer to the motorcycle. So it's measured at 98 decibels. Find its intensity. So again, we have our formula: decibels equals 10 multiplied by log of the intensity over, remember, I0 equals 10 to the negative 12th power. So I'm just going to go ahead and tuck that in there. And we're looking for the intensity. So we're going to substitute our decibels with the level they give us of 98 so we can figure out how intense is it. Let's go ahead and isolate the log by dividing both sides by 10. When you divide 98 by 10, you'll get 9.8. That equals log base 10 of I over 10 to the negative 12. We need to exponentiate or rewrite into exponential form. Excuse this. Time to go home, guys. Don't miss the bus. That's our bus sound here at North Forsyth High School. All right, again, in this step, I am exponentiating or rewriting in exponential form so I can get rid of log base 10. So that will take me to 10 to the power of 9.8 equals the intensity divided by 10 to the power of negative 12. We would need to multiply by that denominator. So 10 to the power of 9.8 multiplied by 10 to the power of the negative 12th equals the intensity. Hey, we're back to properties of exponents. If they have the same base being multiplied, you can add the exponents. So this would be 10 to the power of negative 2.2 for the intensity. That answer is good. Make sure you say negative 2.2. But in decimal form, it's 0.0063 watts per meter squared for the intensity level. There we go. Kind of teeny tiny when you look at it. All right, that's it for this particular lesson. You have quite a few that you can practice. We didn't do any with the cooling temperatures of like your teas and your coffees and soups and stuff. Just kind of follow the formula that you're given in those examples. Hopefully you guys have a great day. See you next time.